in this composition of functions, h of g of -5, instead of an x, we have a -5. So previously we looked at h of g of x, and we said another way of writing this notation is h of g of x. Okay, so before we go ahead and tackle something with a number, let's set this problem up in what we are already familiar with. So our first function is our primary function, which is h. H comes first, right here. So that means I'm going to use x squared plus 4. But remember, instead of writing x squared plus 4, I'm going to leave a space, and then I'm going to have squared plus 4. That's my h of x. And in place of the x, I'm going to put my function g of x. So where I see that space where x was, I'm now going to put in 2x, because that's my g of x. Okay, so I think it might be easier to go ahead and to crunch that out first to simplify it before I put in my number. But I could very easily put in my number for x right now, because remember, when we're looking at this notation up here, that's the same as h of g of x. Excuse me. So my -5 is taking the place of x, because they're in the same position. So if I go ahead and I multiply this out, this is 2x all squared, which is the same as 4x squared. And I have my plus 4. Now I need to substitute in -5 for x squared. So in a very similar way, I'm going to write 4, but instead of x, I'm going to use a parentheses, something squared plus 4. So remember that I have -5 taking the place of x. So I'm going to put -5 in here. Now I can use my calculator and crunch this out if I so choose. I'm going to go ahead and I'm going to just do it longhand. So we have to remember PEMDAS. -5 is all squared, so that's the same as 25. And then I have that times 4 plus 4. So I did my exponent first. Excuse me. And then I have to multiply. 4 times 25 is 100 plus 4, and so then that gives me 104 is my answer. So h of g of -5 is equal to 104.